For this video, we will be discussing about arcs and inscribed angle. For our objectives, we have first, differentiate inscribed angles from central angle. Next, find the measure of an inscribed angle and its intercepted arc. And lastly, solve problems using the different theorems associated with inscribed angles. So let us have first a drill. Determine whether the given angle is a central or an inscribed angle. For the number 1, given this angle ABC, is it a central angle or an inscribed angle? Is it an inscribed angle? For the number 2, given this angle ABC, is it a central or an inscribed angle? That is an inscribed angle. For the last item, given this angle AOB, is it a central angle or an inscribed angle? It is a central angle. So let's recall some of the useful definitions and theorems. The first one is the exterior angle. An exterior angle of a triangle is an angle formed by one side of the triangle and an extension of another side. So given this illustration here, angle BCD is an exterior angle composed by side BC of this triangle ABC and side CD. And our CD here is an extension of side AC. Next is the interior angle. An interior angle of a triangle is an angle determined by two sides of the triangle. In the figure below, angle BAC, angle ABC, and angle ACB are interior angles. Next, remote interior angle. An interior angle of a triangle which is not adjacent to an exterior angle of the same triangle is called a remote interior angle with respect to the exterior angle. So in this illustration, angle BAC and angle ABC here are remote interior angles of this exterior angle BCD since they are not adjacent to the exterior angle. Next, exterior angle theorem. The exterior angle of the triangle is equal to the sum of the two remote interior angles. So in this figure, this exterior angle BCD here is just equal to the sum of this remote angle A plus B. So that is exterior angle theorem. So let's review isosceles triangle. An isosceles triangle is a triangle with two sides equal. Given this illustration, AB here is congruent or equal to the side AC. So that's an isosceles triangle. Two sides are equal. The two equal sides of an isosceles triangle are its legs. This AB here and side AC here are called the legs. The third side is called the base of the isosceles triangle. So this BC here is the base of the isosceles triangle. The angle between the two legs is called the vertex angle. So this angle BAC here is called the vertex angle. An angle which is formed by a base and one leg of an isosceles triangle is called the based angle. There are two based angles in an isosceles triangle. So the based angle are A, B, and C, and angle A, C, B. Isosceles triangle theorem. The base angle of an isosceles triangle are equal. Given this illustration, since side AB here is equal to this side AC, then this angle ABC here is equal to angle ACB. So that's isosceles triangle theorem. Let's now differentiate inscribed and central angle. An inscribed angle is an angle whose vertex lies on the circle and the sides are the chords of the circle. For example, in this illustration, angle ABC here is an inscribed angle since its vertex lies on the circle and its sides are chords of the circle. Inscribed angle versus central angle. So this illustration here is an inscribed angle and this illustration here is a central angle. So an inscribed angle, its vertex lies on the circle. As you can see, its vertex lies on the circle. While the central angle, its vertex is the center of the circle. As you can see here, central angle's vertex is the center of the circle. Next, in inscribed angle, its sides are the chords of the circle. As you can see here, its sides are these chords BA and chords BC. While in central angle, its sides are the radii of the circle. As you can see here, its sides are this radius OA and OB. So its sides are its radii. Next, theorems and postulates on arcs and inscribed angles. So the first one is the inscribed angle theorem. So the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So given this angle, the measure of this intercepted arc ABC is just 1/2 of this arc AC. So for example, if this intercepted arc AC here is 50 degrees, then its intercepted arc ABC here measures 25 degrees. Next, semicircle theorem. An angle inscribed in a semicircle is a right angle. Given this illustration, the angle BRY here is inscribed in a semicircle BAY. Thus, the measure of BRY here is equal to 90 degrees since this is a right angle. Next, angle subtended by the same arc theorem. Two or more inscribed angles subtended by the same arc are congruent. So given this illustration, if angle EAB here and EMB are subtended by this arc EB, therefore, this angle EAB here is just congruent to this angle EMB, since they are subtended by the same arc EB. So next is the cyclic quadrilateral theorem. Opposite angles of cyclic quadrilaterals are supplementary. So given here, circle O, AVEN here is an inscribed quadrilateral. So opposite angles A and E and V and N here are supplementary. Thus, if you add up angle A plus angle E, that is 180 degrees, and angle V plus angle N is also 180 degrees. For question number 4, if the measure of this angle OVL here is 5x plus 10, and the measure of this angle OEL here is 8x minus 11, find the measure of this arc LU. So that is, by the angle subtended by the same arc theorem, we are just going to equate the measure of OBL to the measure of OEL. So that is 5x plus 10 is equal to 8x minus 11. So that's 3x is equal to 21, and the value of our x here is 7. And then the measure of OBL is 5x plus 10. We just have to substitute the value of the x, which is 7. So that is 5 times 7 plus 10. The measure of angle OBL is 45 degrees. Next, the measure of angle OEL is equal to 8x minus 11. Substitute again the value of x here, which is 7. So we have here 8 times 7 minus 11, and that is also 45 degrees. And by the inscribed angle theorem, the measure of this OVL is 1/2 of this intercepted arc LO. So that means that this arc LO is twice this angle OVL. So by substitution, 2 times the measure of OVL, which is 45 degrees, the measure now of this arc LO is 90 degrees. Example V. Oven is inscribed in circle O. Find the measure of angle A and measure of angle E if the measure of angle A is equal to 3x and the measure of angle E is equal to 5x plus 60. So this is the quadrilateral oven inscribed in circle O. So by cyclic quadrilateral theorem, 3x plus 5x plus 60x is equal to 180. Since the measure of angle A here and angle E here is 180, since they are opposite angles and are supplementary. So that's 3x plus 5x, that's 3x. And 180 minus 60, that's 8x is equal to 120. Divide both sides by 8, that is, the value of x now is 15. We are just going to substitute the value of x to the measure of angle A, which is equal to 3x, so that's 3 times 15, which is equal to 45 degrees. That is now the value of the angle A, and the value of angle E is equal to 5x plus 60. Substitute again the value of x here, which is 15, so that is 5 times 15 plus 60 is equal to 135 degrees. So since you already know the different theorems and postulates on arcs and inscribed angle, you are ready to answer Activity 10, Inscribed Angle 1, Activity 11, Inscribed Angles 2, and Activity 12, Validate Me on your Learning Package 5.